So we got sort vowels in a string, medium. Given a zero index string s, permute s to get this new string t such that all consonants remain in their original places. More formally, if there's an index I, where I is between 0 and the length of the string, s of I is a consonant, then t of I is. So consonants stay in the same place order-wise. The vowels must be sorted in non-decreasing order. Return the resulting string. Vowels must be sorted in non-decreasing order. So like A's, then B, A's, then E. So you're changing the order of where the vowels are. They can also appear in lowercase or uppercase. L, E, E, T, C, O, D, E. Okay. The vowels are sorted in according to FE. So the capital letters, capital vowels occur, E, capital O, then there's an extra two E's that become, okay, the spots where the vowels occur are the same, but the vowels themselves are rearranged so that they're in sorted order. Okay. I think the simplest way to do this would be to, what I'm going to do is I will, since it's very finite, the number of consonants or the types of consonants, either capital vowel or lowercase vowel, I'll count the number of capital or uppercase and lowercase vowels, of which there should be 10 types, right? Five vowels, 2 types of casing, and then I'll probably just construct the string based on that, I think. Okay. So let me think. So I think maybe I'll have the vowels be a list. So capital A, capital E, I, O, U, A, E, I, O, and U. And maybe I'll have my answer be an empty array of characters. I think I should probably use a counter to just quickly determine how many of each letter there are in the string. And then iterate over. So I'll say v index is going to be the current vowel that I'll replace with. Current index of vowel to use in replacement. So for every index in range, index, or I think maybe every character. For every letter in the string, I think I actually do need a vowel set. Which is just this thing as a set. And I could convert this to a set, but I think I just probably better just make it static. Like I could make like set of vowels to convert the list into a set, but I think it's just simple to make it a static. I think it's slightly faster, probably. For every letter in this string, if the letter is not in the vowel set, then just append the letter to the answer. Else, what I'm going to do is I'm going to take the current vowel at the vowel index. So like take an A. If there is can counter be modified? Is that a read only object, or can I actually modify the counts in the thing? So I think you can convert that to a dictionary. Okay, yeah, so counter can be treated as a dictionary or hash map. So else, I think here it's just going to be while the current count, whatever the vowel is that I'm at, is 0, then I need to increment the vowel index. So while the counts of the V index is equal to 0, V index plus equals 1, this is find first vowel that still needs to be added, and then answer append whatever vowel is at this index, and then decrement the count of that vowel. Counts of this now. V index is an index, so I think it should be vowels at V index. Counts at vowels of this V index. Decrements. Okay. So goes through the counts of the vowels, like capital A, capital E, capital I, until it finds one that's not equal to 0, so it means that there's some number of them in the string. Then it takes that thing, the vowels at vowel index, which is the vowel itself, appends it to the string, decrements the count of it, and then I'll return the string itself, I think. So let's return joining the letters of the answer. What happened there? Huh. Wasn't particularly fast. I thought this was pretty darn fast. Why wouldn't this be fast enough? Alright, I'm gonna try to run it one more time to see if this is random variation or if it's actually probably not random variation. Yeah, there's something I'm missing here. Or there's some improvement that I can make here. Counts. And I wonder how slow making the counters. Okay, well, let me try to make my own counter or counts. Because technically I don't need to keep track of every count. So maybe it might be faster to keep track of the vowels that I know. So I guess that would be something like I guess I need a default dictionary for the counts then. Counts is a default dictionary of integers. Which is very similar to a counter. So for every letter in S, if the letter is in the vowel set, then counts of that letter is incremented. Okay, see how slow or fast this is. Slightly faster. Consonants remain in their place. I mean, this seems fine. So I mean, I guess I could do something where you sort. Like I pull out all the vowels, create a array of that, sort that array of vowels, and then do a second pass where I just take from the assorted array of vowels every time I see a vowel. Okay, this is definitely just a different way of doing it. I don't think it's faster since sorting is n log n, and this thing is log of n. This is just one pass stuff, but it might be. I don't know. Well, I doubt it, but I'll try it. Sorted vowels is going to be an array. Go ahead and go through S. If the letter is in the vowel set, then sorted vowels will append this letter. Then onto sorted vowels dot sort. And just print out the sorted vowels to make sure it's working like I intend. Capital A, capital O, okay, yeah. And then, so it'll be a second pass. I need an index for the vowel index. So if the letter is in the vowel set, then answer appends from the sorted vowels at that index. Then otherwise just pull, just add this letter, this consonant, and then return the joiner of everything. Huh. Don't know how I feel about that. Well, that is the faster answer. So this is weird in my mind, because I'm almost certain this is time complexity wise slower than this. I'm pretty certain that this time complexity should be O of n, and this is time complexity of O of n log n in the worst case. If you had like all vowels in your string, then the number of vowels that you need to sort is n. But this is one of those things where it does have a amount of overhead to kind of decrement counts and everything every time you pull a vowel, such that the overhead pushes the higher time complexity or the lower time complexity algorithm to take actually more time. But okay. So this is also a solution using sorted vowel, using sorting of vowels, which is going to be O of n log n. And I don't think there was much of an improvement for using a default dictionary versus a counter. This is solution using count of vowels and replacement based on those counts. Technically this is O of n. Okay, so summary, this is the slower in practice. And let's count the number of uppercase and lowercase vowels, construct string by iterating over every letter and appending some letter to an answer array of characters, which is initially empty. If letter is consonant, is a consonant, append that letter. If letter is a vowel, append the earliest vowel, the alphabetically I guess this would be lexicographically, lexico, lexicographically, smallest letter with non-zero frequency and decrement that frequency. So that was this stuff. Like you have accounts. You also have the order that you try to find it in. So pull out the earliest vowel that is not zero. If it is zero, the frequency is zero, then go to the next index, or go to the index of the next vowel. And then once you find that vowel, append it to the answer, decrement the count of that vowel. Then after loop, construct a single string by joining characters of answer array. Faster in practice is going to be create or push all vowels into a single array, append to iterate over letters, string, appending to array if not constant, if it's a vowel, sort the array to another pass over letters of string and either append to answer array the letter, consonant, or the current vowel in sorted array, sorted vowels, incrementing index each time. After loop, construct the single string from answer array and return. So that's this thing. Go over letters. If it's a vowel from vowel set, append that letter to some array for the sort vowels, sort, and then do a second pass and either append the letter if it's consonant or append the current indexed vowel. Alright, time complexity. This is going to be slower in practice. Is O of n, since it only needs two single passes over all letters. String. Faster in practice is O of n log n, since it requires sorting the array of vowels. This is unusual, but I think it's that the faster in practice solution has a kind of slower big O time complexity, but I think that's due to some of the overhead in modifying counts that the slower in practice solution requires. Alright, space complexity, this is going to be O of 1 since the, well, no, that's not right. O of n for the faster in practice solution to have array of vowels, array of sorted vowels from part. For the slower in practice solution, that actually should have, it'll be O of 1 since it only requires like 26 counts. Let me double check that. Yeah, so the earlier solutions which had that was like 19.6 megabytes, and the other one had 21.1 megabytes, so yeah, it was slightly more megabytes for the keeping track of the vowels. Cool beans.